This is the story of the fastest wind ever measured on the surface of the earth and the machine that caught it. On May 3rd, 1999, a truck with a radar dish bolted to its bed was racing along a highway in central Oklahoma, pointing its beam straight into the heart of a monster. What it recorded that evening still sits at the very top of the record books, and scientists have been arguing about it ever since. If you like stories where the science is the twist and not just the wreckage, subscribe. On this channel, we take the biggest events in Earth science and show you how we actually know what we know. This one is about a single number, where it came from, and why the people who measured it refused to call it official. Let me tell you about the machine first, because the machine is the entire reason we have a number at all. For most of the 20th century, nobody could measure the wind inside a violent tornado. The instruments strong enough to survive it did not exist, and the ones that existed could not survive it. Anemometers get torn apart. Weather stations get flattened. So the strength of a tornado was always worked out backwards, from the damage it left behind. That is what the Fujita scale does, even today. It does not measure wind directly. It reads the wreckage and estimates the wind that must have caused it. A flattened house means one thing. A house swept clean off its foundation means something much worse. The rating is a very educated guess. Then came the Doppler on wheels. It was the idea of a researcher named Josh Wurman, who took the kind of Doppler radar that normally sits fixed on a tall tower and mounted it on the back of a truck. The plan was simple and a little bit insane. Instead of waiting for a tornado to wander close to a permanent radar sitting 100 miles away, you drive the radar to the tornado. You get close, you aim the dish, and you read the wind directly by measuring how fast the rain and the debris inside the funnel are moving toward you or away from you. For the first time, scientists could point an instrument at the most violent weather on the planet and get a live number back. On the evening of May 3rd, that truck was in exactly the right place at the worst possible moment. The tornado had formed southwest of Oklahoma City and was grinding northeast toward the suburbs. Near the town of Bridge Creek, it reached the top of the scale, an F5, the highest rating that existed at the time. As it passed close to Interstate 44, Wurman's radar locked onto it and took its reading. The number that came back was 301 miles per hour. 301 miles per hour. To put that in plain terms, that is faster than the top speed of a Formula One car, except made of air, and carrying 2x4s, vehicles, and entire pieces of houses. And here is where the science gets careful, which is exactly why this story belongs on this channel and not on the ones selling you a cleaner, scarier version of it. That 301 figure came with a margin of error of about 20 miles per hour in either direction. So the real reading sits somewhere between roughly 280 and 320 miles per hour. You will see plenty of videos and articles quote the number as 321 miles per hour, flat as a hard world record. That higher figure comes from the top of the error range, not from some separate, more precise measurement. The honest version is the one with the uncertainty still attached to it, and that uncertainty is not a technicality. It is the whole point. It matters because of where the radar was actually looking. The beam did not read the wind at ground level. It read it about 100 feet up in the air, above the thin layer near the surface where friction with the ground drags the wind speed down. The wind moving that fast at 100 feet is not necessarily the wind that struck the houses below. That gap between what the radar saw up in the funnel and what the tornado did on the ground is the reason for the biggest twist in this entire story. The United States National Weather Service does not recognize that 301 mile per hour reading as an official record. It never has. Officially, Bridge Creek Moore is an F5, rated the exact same way every tornado is rated from the damage. The single most spectacular wind measurement in the recorded history of the planet sits outside the official record books on purpose, because the agency will only certify a wind speed it can tie directly to the ground. There is one more layer to this, and it is a strange one. On the original Fujita scale, there was a category above F5. It was called F6. It was described as an inconceivable tornado with winds above 318 miles per hour. It was never meant to actually be used. It was a theoretical ceiling, a number so high that no real tornado was expected to reach it. And yet the top of Bridge Creek's error range brushes right up against that line. That is why, for years, people have asked whether this storm briefly became the only F6 in history. The official answer is no. No tornado has ever been formally rated at or above that threshold, and the Weather Service has firmly kept Bridge Creek as an F5. The inconceivable category remains exactly that. Among tornado researchers, though, that reading still stands as the highest wind ever reliably measured in Earth's atmosphere. Both things are true at the same time. It is the record, and it is not the record, depending entirely on who you ask and what they are willing to put their name on. Wurman and his colleagues later published the measurement in the Bulletin of the American Meteorological Society, in a 2007 paper on the low-level winds inside tornadoes and what they could mean for cities. That number was never just a trophy, though. The damage on the ground told its own story, and it was almost impossible to believe. In Bridge Creek, entire neighborhoods were scraped down to bare concrete slabs. Trees were stripped of their bark. Cars were thrown hundreds of yards. In one spot, the tornado peeled a layer of asphalt straight off a road. 12 people died in Bridge Creek alone, most of them in mobile homes. By the time the tornado finished its track, it had traveled 38 miles in about 85 minutes, killed 36 people directly, and caused around $1 billion in damage in 1999 money. But even here, the science refuses to let the number tell a simple story. When structural engineers from Texas Tech University surveyed the destroyed homes, they found something uncomfortable. Many of the frame houses that were swept away had been built below code, nails that were not driven improperly, homes that were never bolted to their foundations. Their finding was that a well-built, properly anchored house should have withstood winds in the range of an F3, around 150 miles per hour. Some of these homes came apart before the strongest winds ever reached them. So part of what looked like pure 300-mile-per-hour power was, quietly, also a building failure. That night changed how people get warned, too. The Norman Weather Service office issued the first ever tornado emergency, a brand new level of alarm above an ordinary warning, as the storm bore down on southern Oklahoma City. Bridge Creek got about 13 minutes of lead time. Moore got more than half an hour. Local television coverage, especially the meteorologist Gary England, is widely credited with driving people into shelter and saving lives that would otherwise have been lost. So, what do we actually know about the fastest wind ever measured on Earth? We know a truck with a radar dish drove up to an F5 tornado and read 301 miles per hour, give or take 20. We know that reading was taken 100 feet up in the air, which is precisely why the National Weather Service will not stamp it as official. We know researchers still treat it as the highest wind our instruments have ever caught. And we know that even a number that extreme was tangled up with where the radar happened to be looking and how the houses underneath it were built. That is the difference between a record and the truth. The record is a single clean number you can put on a screen. The truth is a machine, a margin of error, 100 feet of air, and a building code, all wrapped around one afternoon in Oklahoma that we are still arguing about more than 25 years later. If you want more stories where the measurement itself is the mystery, that is what this whole channel is built on. I will see you in the next one.